Alright, so this is going to be our final one with really just exploring the limit of a function. We're going to talk about an infinite limit. And basically this is when a function blows up to infinity or goes down to negative infinity. You know, like asymptotes and things like that. Sometimes that happens. You took algebra, right? You had to graph those rational functions, which means like x's over x's and stuff like that. Whatever. Let's get into it. So infinite limits. So what I got here, I just got a function. Because we're gonna talk about the function first, and then we can dick around with all the limit stuff. Because we gotta know what it looks like. I'm telling you, if you don't know your parent functions, you're gonna have a real hard time answering a lot of these questions. Especially through this section where it's called Find the Infinite Limit. It's about where it's going. Now you can cheat and just throw it into Desmos as you do your homework and stuff like that, but it won't work when you go to take your test. You should be locked out. So you're gonna have to know what these parent functions look like. I'm telling you, it's a real simple thing. Just having the parent functions that have been talked about. You know, like a parabola x squared. But here's the big one. We gotta know this one. Like y equals 1 over x. What's it look like? And this is a parent function. You should just have it on lock. I don't need you to have a bunch of numbers in there, but just look at it and go. 1 over x looks like this. This is what's called the reciprocal function. There it is. It's the reciprocal function. You're not allowed to plug in frickin' 0, right? Come on. You know you're not allowed to divide by 0. There's some sort of asymptote right here at x equals 0, right? Because don't divide by frickin' 0. Know what I mean? So, when we want to go take a limit of one of these things, well, let's go look. So let's go take the limit as x tends towards, and let's go to 0 from the left-hand side of our 1 over x and see where we end up. What's that equal to? So we're like from the left-hand side of 0? Well, 0 is the y-axis. So we're like, go this way. Now, where is it tending towards? Well, shit, that's tending down towards negative infinity. This is equal to negative infinity. Well, it's not really equal to, because that's not a number, it's a concept. We're just basically saying that the limit is blowing up to the smallest number you could possibly think of, the most negative. Well, now let's write a limit again. Let's go find the limit as x tends towards 0 from the right-hand side of our 1 over x. That graph that we have graphed right there. We want to see, well, where's this one going to? What did you see from the right-hand side? Whew. That thing just blows up to positive infinity. And while infinity and negative infinity are just concepts, they certainly aren't equal to each other. That's not the same thing. All right, negative 5 doesn't equal negative, or negative 5 doesn't equal positive 5. Even though they're not numbers, just doesn't equal. Therefore, this little 3 dots, I might write it every once in a while. That means I'm about to say something awesome. Actually, I mean boring. I mean mathy. It just means therefore. So we say that the limit as x tends towards 0 of 1 over x, well, that doesn't actually exist because one's going one way at 0 and one's going the other. They're not pointing towards each other. Okay? So there is no limit for the actual as it goes to 0. Now from the left, it goes to negative infinity. From the right, it goes to positive infinity. Okay. Now let's move to another one. I got one right over here. Hey, it's very similar. It's just f of x is equal to 1 over x squared. So it's not 1 over x this time, but 1 over x squared. Now, can it ever be negative when you square something? Nah, we're not going to deal with those complex numbers, especially not in the Calc 1 class. We deal with real numbers. None of that bullshit with the eyes, okay? I mean, we might discuss it for a second, but you don't have to deal with that. So here is our parent function. That we should just have this one on lock. Being like, hey, it looks just like the other one, except everything is positive. It looks just like 1 over x, except everything's positive, right? This thing down here is flipped up into the positive area. Cool. And it still can't have 0. X can't equal freaking 0. Oops, my bad. So as we look, well, let's go look at our limit as x tends towards 0 from the left. Our limit as x tends towards 0 from the right. And then we'll look at just our limit as x tends towards 0. And if you're following along, you're like, I see what's happening. I see this. So what do we get? If we come from the left of 0, we blow up to infinity. So we write infinity. As we come in from the right of 0, we're still blown up to infinity. Well, they're going to the same spot. They're both tending the same direction. Therefore, we can say that this limit as x tends towards 0 of 1 over x squared is also going towards infinity, since it's tending towards the same spot. Now, there is some ambiguity there because that limit doesn't technically exist, but we still write infinity. Because infinity is not a number. For a limit to exist, it must achieve an actual value. But we're going to write it down like this, and you're going to have to play these games throughout your homework and web assignment. All right, let's do a couple more. And really, the moral of this next story is, do you know how to graph? This really comes from, I mean, you can use crutches like Desmos, and I would do that at first. As you're doing your homework, check out Desmos. It's a free graphing software. Just type it into frickin' Google, and the shit pops up. Anybody can use it. I mean, if I can figure it out, you can figure it out. And just to look at these functions, but this is stuff you've technically passed a class saying you know how to do this. So graphing something like this shouldn't be that big of a deal. You should be able to look at this and go, oh, x can't be -3. Cool. X can't be, or not -3, +3. My bad. Can't be 3, right? Because that would make the denominator equal 0. So you can be like, that's it, x equals 3. You got some sort of asymptote there. We also have that we have a y or an x-intercept right there, right? When y equals 0, that'd be like plugging in x equals -4. So we have a point here. Oh, we also have the idea of spectrum. Oh, you remember this in college algebra, right? The degree of the top, if it matches the degree of the bottom, it's just the two coefficients over each other. Is going to be your horizontal asymptote. That's 1 times x, that's 1 times x. Do you remember all this? I'm purposely trying to scare the shit out of you because at some point in time you're supposed to know that, and you're still supposed to know this. So we actually have right here at 1, we got this little horizontal asymptote. So that's telling us that we can graph this thing as such. I mean, mine's not perfect. And that's what that graph looks like. Can you do that graph? Could you do what I just sorry, my graph is bothering me. I have to kind of fix that a little bit. It needs to be more like this. Oh, there we go. Can you graph that? You're supposed to. I don't know, that's one of the toughest things we do. Even my star students in college algebra and pre-calculus coming into calculus 1, they still struggle with this a little bit. So if you are, it's no big deal. Just figure that shit out, right? It's not where you are, it's what you're going to do about where you're at. So let's go look at our limits. Let's go look at a limit as our x tends towards 3 from the left-hand side of x plus 4 over x minus 3. So from the left-hand side, we can see that this is going to blow up down to -infinity. And then if we look from the right, we can see, I mean, come on, you see it by now, don't you? Don't you see it? Since the asymptote is going 2 different directions, we have our function of this one from the right of 3. That's blowing up to positive infinity. Therefore, there's those 3 dots saying we're about to say something freaking awesome or astute, or like we've come to some sort of freaking conclusion. And we can say that since negative infinity doesn't equal positive infinity, that this just doesn't exist. On to the next. All right, parent functions, and parent functions. Oh, gobby, right? You can graph this, no problem, huh? It's just a simple little transformation and just a parent function. You got it. Y equals ln of x. You know how to graph this, don't you? Natural logs. Just looks like that. Just looks like this. So when we go to graph ours, let's take a look. We're like, well, wait a second. If it's x plus 2 inside of here, see that plus 2? Do you remember your transformations from pre-calculus or algebra or your IM, whatever? That just shifts it to the left, not to the right. It's the opposite. X's always do the opposite of everything whenever it's inside the function. So it's going to take it and shift it to the left by 2, which is saying our asymptote there at 0 is not going to be 0, but actually over here at -2. So, whoa. So that's how our graph. There's our h of x is equal to ln of x. Y is equal to ln of x plus 2. Where we have this little asymptote that kind of comes down right there at -2. But there's nothing to the right of it because you're not allowed to plug in anything but positive values into logarithms. So if we look at this and we say the limit is x tends towards 2 from the left hand, or negative 2 from the left hand side of our ln of x plus 2, well, that's freaking nonsense. That's nonsense. That's not even in the domain of the function. Value is smaller than negative 2. We're not allowed to even plug into there because it would create 0, which we're not allowed to have in the argument of the natural log or any logarithm for that matter, and no negatives. So this is just nonsense. I mean, it's just straight nonsense. This does not exist. And that's one of the examples where one side of the limit won't exist because there's nothing in the damn function. There's nothing to the left of negative 2. Now, if we're to take the limit as x tends towards negative 2, we come from the right-hand side. Well, shit, now there's something we can play around with. Huh? From the right-hand side, bang, we're taking off down towards negative infinity. So we can state this thing as negative infinity. Therefore, the limit as x tends towards negative 2, just period, of ln of x plus 2. Well, since there was no shit on the other side, it was impossible for the limit to actually exist because the limit from the left must equal the limit from the right. And if there's no frickin' limit from the left or the right, that shit will not exist. So there's the game. You know your parent functions, because that's how we're going to have to play this. You're going to get all kinds of crazy shit inside your homework asking you, like, where's this limit going? So, this is how we play. I'll see you in the next one.